Hello, Bell, or Dr. Grissom, whoever's watching this for software engineering. I'm going to be talking about Udacity and object-oriented software and UML. So pretty much like object-oriented programming is what you talked about, or what we learned in CS 125 and a little bit in 120. Pretty much it's just like a bunch of classes, instant variables, and methods alongside like inheritance and all that stuff. So you talked about why we want to design before coding, because if we code without any design, we could end up having to go back and have a lot of technical debt where we have to recode things, refigure things out, and if the person who wrote it didn't comment things well enough, then we have to try to just decipher what they wrote. Yeah, so when we design classes, there's a lot of redesign, and it's hard to collaborate unless we're using some sort of communication system like, say, Discord or like Slack or any of those kind of things. And if we design classes before we code, we could avoid having that technical debt. We could increase our capability of coding parallel to one another, so we could have multiple people working on a project, and we could also have like class interfaces. I know we talked about interfaces way back when in the beginning of time, or by beginning of our college careers. So that way we could have like me code class AB and somebody else code class D and E. So our goal is to pretty much turn like our high level descriptions into our software design. So we're going to be using like the paragraphs of text, all the user stories that we created, and then we're going to look for keywords inside those to construct our object-oriented programming. So like our nouns would be classes, our adjectives would be attributes or instance variables, and our active verbs would be our methods. After that, you gave some examples of that in different text, some running examples. So when we choose our attributes, we don't need to have data types quite yet. And then when we're making our methods, we need to be careful of what classes we add the methods to. So yeah, and then we get into the UML structure diagrams. So these diagrams look very similar to the diagrams that we did in databases, just that they have a bunch of different lines and meanings now. There's a lot more of them. So pretty much like the top little bar on each little box is like the class name, then there's the instant variables underneath, and then underneath that, and then the third box would be the class methods. So if a variable or a class method, or no, if an attribute has minus sign next to it, it means that it is a private variable or a private attribute. If it has a plus sign, then it's a public attribute. You could also put like the type next to it. So if it's like a color, string, double, int, float, all that good stuff. And then we have our class methods that are underneath that also have the same type of notation with the plus and minus. And then we get into the class relationships. There's a bunch of different class relationships that are different from obviously that database. There's association, inheritance, realization / implementation, dependency, aggregation, and composition. So inheritance is pretty general. It's just an arrow with it being open, and the arrow is on the superclass, so it's pretty much like A is going to B. Association is where like A utilizes B, so it's using it. So A is related to class B in some given way, and you could link like more than two classes to that. So alongside that, there's multiplicity. So multiplicity is like a line with two numbers on each side. You could have 0 instances of one thing. You could have 0 to 1, or 0 or 1, exactly 1, 0 or more. All the notation varies. But like in your example that you have on your PowerPoint, it's like a car. You have one car will have 4 or 5 wheels. Like the fifth is obviously being the spare if you have one. Then you kind of continued on to class relationships more. You talked about aggregation. So B has A. Aggregation is like an arrow with a open diamond at the end. So there's that. These aren't as common, but they're there. And then composition is similar to aggregation, but it represents the real world and whole world relationships. And then you have realization and implementation. So this is A implements the B interface. That's realization and implementation. That is a dotted line with an open arrow, a fully open arrow, like as a triangle. Then there's dependency. So A depends on B because it uses it at some point. This is not a strong relationship. This is a very weak relationship as it's a dotted line. And then B is also not a variable of A, but we might be passed. So, yeah. And then as for, sorry, I'm also at work recording this, so I'm getting messages from work. But we'd use a UML for our mobile app development. I have to open up a meeting right now, actually, so I'm gonna do that really quick. But we use that here. We used it recently to kind of redesign a little bit of our database structure. We didn't actually make a UML before, but by doing this is kind of to get rid of our technical debt, because we have built up quite a bit of technical debt over the past few months, just because we have been working so quickly. So we pretty much use UML to kind of get everybody together and figure out everything and kind of make it in an organized design so that we could understand. I think it's very useful. We figured out a way now that we could fix our issues that we had before. So yeah, thank you. I have to go to a meeting now. Bye-bye.